Hi everyone, this is a dedicated video on gold exploration. Its basic overview. So let's start with introductory basics. So as we know, atomic number in periodic table, atomic number of gold is 79. It belongs to transition metal. Gold is occurring between silver and rhodium. Rhodium is artificial element which is not existing in nature naturally. The artificially synthetically created element, and group it belong to group 11 of periodic table, and period wise it occurs in the sixth period between platinum and mercury. So it is one of the most stable isotope, often occur as native state. In native state, its stable isotope number is 197, and physical properties in normal pressure temperature condition is mostly characterized gold as slightly dense element with 19.32 gram per cc. Melting point is 1064.58 degrees Celsius. So naturally, uh, whenever gold first crystallize, that magma has to be very high temperature magma. From that about 1065 degrees Celsius only gold can crystallize first in cubic system, mostly isometric. And as per Mohs scale of hardness, its hardness is belong in between 2 and 3. So this is the primary information should be kept in mind whenever anybody is interested in gold exploration. Next is, let us see, as per the McQueen 1997, who have characterized different deposit types of gold and its geochemical association with other elements, which can be acted as, often it utilized as pathfinder elements in gold exploration. So that association must be understood clearly, and we should not identify pathfinder blindly. We must understand the deposit type as well. So certain pathfinder element can be geochemically associated with gold for particular type of mineralization, whereas that same pathfinder element for other type of gold mineralization cannot be useful. For example, for mesothermal type, gold usually occur with silver, antimony, whereas for example here in Carlin type decimated pyrite, arsenopyrite gold bearing system, mercury also is coming into picture. So uh, this this is a very big chart. Anybody can see. You can pause this and you can go through. Next is some important information which I would like to share with you. As you know, gold does not react with oxygen to form stable oxides, and its principal oxidation states are only 1 and 3, plus 1 plus 3. Most common compounds are AuCl3 and HAuCl4. And in previous video I have discussed, earlier I discussed how that metallic bond play a significant role in EH video I have discussed, which is available in YouTube. Here so many free electrons always available apart from that electron cloud as well. So it is that whenever some potential difference is created, those free electron can be moved. So gold act as electron donor. That means it gets oxidized. Oxidation means loss of electron. Now, gold evolves as a siderophile element from FeNi core at crustal spreading center. and is present in FeNi sulfides in the upper mantle. So this is the preliminary stage. I am trying to evaluate how it got evolved during partial melting of these materials. So these basic fundamental primary things, when it got partially melted, then the sulfides are partly consumed, while gold and other metals rise with basaltic fluids into the crust along the mid-oceanic ridges or subduction zones. That is the reason most of the old preliminary gold, non-sedimentary gold, are found in association with Archean greenstone belts and sometimes along with quartz vein. Fluid that can carry more than 10 ppb gold are excellent ore forming solution. Concentration of ore or removal of non-ore is important for enrichment. Yes, gold, to make a deposit or to make a good source rock, concentration of gold has to be enhanced. How it can be enhanced? Either gold can be added, or from entire system, apart from gold, other things, if some there is some process other than gold, if it is removed all other things, so naturally percentage wise gold will be enhanced. Such enriched gold concentration in source is important in minimizing concentration factor. So what is concentration factor? See, this is an important fundamental diagram where, see, in number one, source is there. Source gold in average cost we must be knowing 4 ppb, and gold in enriched source is up to 20 ppb. So that enriched source, when it suffers certain fluid action, it will be easier for those enriched source to play important role in further mineralization compared to crustal source, because in source metals, ligands and combinations those should be present. Then with proper transportation mechanism and availability of proper fluid migration pathway, with other factors like mechanical biological factors, it can be concentrated. And finally, in physical chemical trapping mechanism, preservation mechanism, it can lead to formation of a deposit. Okay, so let's do some interesting calculation regarding concentration factor. I would like to share two questions. If one question is solved, automatically second one is also will be solved. Same thing. Now question is, if the average crustal content of gold is 4 ppb, what will be the concentration factor? That means how many times of enrichment is required to get 1 ton of gold at with an average of 5 ppm, and another one is 10 ppm grade. Both can be solved. Firstly, in case of 4 ppb gold in crustal rock, that means 4 tons of gold content is found in 1 billion tons of rocks, parts per billion. That means 4 ppb means 4 ton in 4 billion ton, 1 billion ton per billion, 4 tons per billion ton. So then that means 1 ton gold, 1 billion divided by 4, 2.5 into 10 to the power 8 tons rock. Similarly, in case of now 5 ppm or 10 ppm gold grade, using the same calculation, 1 ton gold in 5 ppm, how much? 5 ppm. Similarly, it will become 2 into 10 to the 5, 10 to the power 5 and 10 to the power 5 tons respectively. So therefore, if we divide 2 into 10 to the power 5 divided by this 2.5 into 10 to the power, automatically concentration factor will come. So for 5 ppm gold, it has to be enriched up to 1250 times. For 10 ppm, further 2500 times. However, if you use 20 ppm, that means enriched source, better source, So for 20 ppb, what will be the function? 20 tons of gold content will be found in 1 billion ton. So 1 ton will be content in 5 into 10 to the power 7 tons. Now similarly 5 ppm and 10 ppm respectively, same 2.58 and same 2 into 10 to the 5 and 10 to the 5 tons will come. So again similar way, if we divide this, it will come to 50 and 500 respectively. So now you can see, for 4 ppb crystal source, concentration factor to get 5 ppm will be 1250, whereas for 20 ppb enriched source, to get same 5 ppm gold, only 250 times concentration factor is required. Similarly for 10 ppm, only 500 times enrichment factor is required. That means to have better enhanced source, enrichment factor, concentration factor should not be required that much. So that is very effective. Now let us discuss briefly some geochemical property. So as we know, naturally occurring gold is never pure. Hydrothermal solutions leach other elements as well as gold from rocks through which the solution passes, and that hydrothermal solution property is very much important to understand. So gold forms natural alloys commonly with silver, copper, mercury, tellurium, and apart from this also, and in certainly some less commonly observed complex are gold titanium complex, gold bismuth, gold palladium, lead, and zinc complex. But that is also possible, but in general gold mostly occur along with silver, tellurium, mercury. Okay. Now, but these are not impossible to get. Like varieties in such primary ores include cuproorite, whenever it is associated with copper, then porpesite for palladium rich gold, bismuthorite for bismuth rich gold. So these minerals are not found in alluvium detritus, of course, but their presence along weathering zone can give clues towards geological history. So it is primary in nature. More importantly, further, one thing we must understand: impurity with gold. When some mixing gold in lab also it is examined, when gold is associated with iron, thus blend gives blue color. Gold with higher silver content than copper gives green, then pink or rosy color when 50% gold, 45% copper and 5% silver is mixed. Then white color gold when nickel, zinc, copper, tin, manganese, nickel is often bleached together, then blended together. Then yellow color when most of the percentage is comprises of gold, about 50%, then 25% 5% silver, 25% copper. In that case sometimes yellow color comes. Now coming to the basic aqueous geochemistry of gold, because solution chemistry, fluid chemistry, those things are very important to understand, and that will lead to evaluate depending upon the rock chemistry. If we analyze the possible condition, geochemical environment, fluid chemistry, we'll be able to understand which complex will be formed, like gold hydroxide, gold dichlor, gold with chlorine association Cl2Cl4, then hydrogen sulfide association, thiosulfate, cyanide association, gold with organic matter, colloidal gold. So these possible origins are explained in this table. I am not going through this because this is already written, and I have, as I have told, I used to prepare the slide such a way that reader also can get benefited. So this same slide, if you pause, you can go through. My verbal as well as pictorial depiction is always useful for whoever seeing this presentation, they also can use this in future as well as ready made material. Now further, few important points. The dissolution of gold chloride requires highly acidic saline and oxidizing condition. Acidic means pH has to be low, saline, and then oxidizing means EH must be little higher as provided by deep continental brines. And precipitation occurs under reducing condition. For example, reducing means when gain of electron, further other electron donor has to be available, other electron donor. So that must be understood. Like in the presence of ferrous iron, it easily reduce gold. Hmm? The most important sulfur species for gold mobilization are hydrogen sulfide H2S and thiosulfate. In just previous slide, as I have discussed, and sulfide is oxidized to sulfate in the presence of oxygen, although the intermediate product thiosulfate may be formed during pyrite oxidation under neutral to alkaline weathering conditions. Next is under highly reducing condition, gold bisulfate complex is particularly important for hydrothermal transport of gold. However, bisulfate complex not only a restricted occurrence in the superzone zone. Okay. Organic complex capable of mobility of gold in soil profiles include cyanide complex. So all the complex whatever we have discussed in tabular form, certain points which are noteworthy is written here. So cyanide produces gold mobility. Apart from other than that, certain plants and microorganisms are known to release cyanide and can indirectly helpful in accumulating gold. Gold readily forms molecular aggregation up to 5 micrometer size, that is colloidal size. Okay, so colloid form is an important mechanism for the mobilization of gold. Now, some alloys of gold, these things should be understood because whenever we explore in certain terrain, these kinds of alloy, naturally formed alloy is often observed, which are in lab also prepared artificially, but nature also produce sometimes often. So the principal natural alloys of golds are native gold. Native gold means purely defined of gold, but I'll come into this. Electrum, amalgam, and tellurides. Alloys of gold means native gold means pure gold, but why are we are calling that alloy? I will tell that. Native gold is in itself an alloy because normally it containing an isomorphous mixture of gold, maximum gold, but some amount of silver will be always present in proportions of 4 to 15% by weight. Okay, because of that, native gold is also considered as an alloy. Gold in native gold is rarely less than 1%. Most of the times 4 to 50% gold always there, but still in native gold also silver percentage is more than gold. Native gold in which silver is greater than 15% and less than 50%, that is classified as a separate mineral, that is electrum. So native gold, afterwards that electrum we have talked about. So that electrum means when in a native gold 15 to 50% silver will be there, that will be classified separately as electrum. In general, electrum is a common name given to all intermediate varieties in the isomorphous series between gold and silver. And the physicochemical properties of electrum vary with silver content. Naturally, 15 to 50% is wide range. Okay. So physically, with increasing silver silver content, gold color also changes from yellow to near white. Metal becomes less dense. As much as silver impurity will be added, it will become less dense because silver is less denser than gold. amalgam. Now amalgam means it is a complex of gold and mercury. Okay, and gold tellurides, it occurs widely in both epithermal Archean greenstone belt type deposits. Most common varieties are petzite, AgAU, equal to Te, tellurium, sylvanite, calaverite compounds. So it is often called oro bismuth. That is also sometimes are there. Now, as I have discussed, gold always containing some impurities. So purity of gold, how to measure? It is measured in terms of fineness. Often we must have come across this type of terminology whenever gold exploration. Uh, we might have read gold exploration. Then, so fineness is a rough and sometimes uncertain indicator of deposit type, but it a definite indication of purity of gold. More fine gold means more pure gold. Gold percentage is more. For example, higher fineness gold is typically produced in larger of grains. So high purity gold means often grain size itself big, relatively larger, and it is indicative of deep, high temperature, high pressure mesothermal solution action. Then by epithermal solution, low temperature will be adding some impure things also, which tend to produce smaller particles of gold of lower fineness. Okay. So, however, there is a number of other factors which may contribute to fineness as follows. These are written. So, other factors, that is why I have written fineness is a rough and sometimes uncertain. These are the uncertainty factors like temperature, pressure, so other solutions, multi-stage nature of hydrothermal solution, superposition of new mineral stages, like that. So many factors are there. So it is a rough estimation, but not always a fingerprint type thing. Now, gold grain morphology. This is also very important for exploration geologists who are working in field exploring gold. So, because gold is one of the last minerals to crystallize out under hydrothermal condition. I am not talking about magmatic condition. Magmatic condition automatically it will crystallize that melting point, that crystalline solidification point about 1000 degrees Celsius. There it will be crystallized from melt magma. But here I am talking about hydrothermal condition. In hydrothermal condition, it is the one of the last minerals to be separated out. Okay, because depending on the saturation, deposition, and thus tends to fill cracks. Whoever occur separate out at the last naturally cracks, whatever cracks or available porosity permeable position will be available there, it will be settled down like quartz vein. Then quartz itself is a crack filler, so along with quartz that gold will also come. That is why often in quartz vein load gold type deposits mineralization are common. The gold grains are molded by geometry of opening into aggregates of irregular shape and size and commonly contain inclusion of quartz and other rock forming minerals, as I have discussed. So it will take the shape of that available area. So it molded by geometry of opening. It is already, it should not be elaborated. Automatically anybody can understand. Although physically gold grains may be crystalline, like octahedral, rhomboidal, dodecahedral, cubic. They occur more frequently in other forms as well. These forms include aggregates of irregular shaped grains in quartz and other hydrothermal minerals like reticulated, dendritic, phylpon, spongy, massive, and scales. So many other different type of irregular shapes of gold grain can be found. That is the beauty of gold exploration. Size, shape, and surface texture are strongly influenced by their depositional environment and associated with other minerals. Gold tends to be coarser grain when deposited in quartz veins with only small amounts of pyrite, but may occur in an extremely finely divided state in massive pyrite or other sulfide ores. When pyrite itself in grain scale, it is often observed pyrite contain gold inclusion. So those gold will be smaller. This is a simple table where source of gold either magmatic or hydrothermal and then sedimentary environment. See, again, these terms I have discussed in my earlier video. What is supergene, what is hypogene. In EH video also I have discussed elaborate in an elaborate way. So you should understand. So in bedrock source, in placer source, placer is secondary sedimentary process. Here also hypogene origin, oxidation zone, hydrogenic zone. Okay, and then hypogene, supergene in case of bedrock source. Morphology of colors. These are different exploration guides. Where depending upon these characteristics, we can narrow down our targets. Similarly, for secondary source, it is taken from Gusti in 1986. He have characterized alluvial pressure to alluvial pressure. So that is in term of distance from source. For this kind of study, regolith mapping, regolith understanding is very much essential, and I have already discussed regolith mapping earlier in my earlier another one video. So whoever interested, they can also refer that regolith. And then alluvial means whatever material, just it is mostly in this case weathering is important and mass wasting, not erosion. Erosion will come into picture just afterwards, that is with increasing distance. Erosion means weathering plus transportation. So with more and more transportation, more and more erosional features will become prominent, and then it will be regarded as alluvial pleasure. So surface transporting agents will be playing other roles, significant roles. So these are the different properties: gold grain, morphology, rim effect, abrasion. Yeah. But whoever interested in Archean greenstone belt and associated gold exploration, these things are not that much important. This is for placer gold. But however, this alluvial portion, this portion where I am moving my cursor right now, arrow, this portion is also important everywhere. Now, exploration of gold. In brief, whatever what are the knowledges required for exploration of gold? In brief, preliminary knowledge of geological study, geomorphic reconstruction, selection of potential exploration targets, regolith mapping, geochemical sampling, including lithopedo, stream sediments wherever it is necessary, as as per the objectives. Primary and secondary geochemical dispersion identification. This is very important, and depending upon that identification, proper sampling, detailed scale sampling is also required. Then evaluation of gold rock paragenesis, so that overall genesis can be understood, and that genesis will further guide in narrowing down target. Further same knowledge can be utilized in adjacent area in green from greenfield to brownfield areas. Then planning and site selection or the others. So overall there are so many strategies are involved which cannot be explained in a single video. For that I have just made one simple template. Depending upon the situation, the template may be varying, but overall project overview, project title, location, project duration, objectives. So what are the objectives? Gold exploration means define the extent of gold mineralization, access economic viability, identifying potential mining sites, that is the future aim, and comply with, this is also important nowadays, environmental and regulatory standards. Okay, then when study after literature and all this completion, first thing in field geological geophysical survey. Okay, then in geophysical it has to we have to identify certain key features, map rock structures, mineral occurrences. Similarly, geophysics must be involved, airborne ground based geophysics, wherever inaccessible portion for subsurface better understanding. This gravity, magnetic, electromagnetic, IP resistivity, all will be requiring, and based on that certain small areas has to be targeted. There also geochemical analysis, then proper soil sampling, rock sampling, stream sediment sampling has to be carried out, and based on that data, drilling strategy has to be fixed, and then define we have to define drill targets, different type depending upon the terrain and other logistics. We have to um, properly decide which type of drilling will proceed at the sea or river circulation or diamond core drilling. Then proper lithologging, sampling. Drilling means sampling, but proper way of sampling is knowledge is required. Oriented core recovery is required. Then finally resource estimation, data after compiling data very cautious way. Then resource modeling, then economic evaluation, metallurgical testing, then preliminary economic assessment. This is preliminary economic assessment because it involves lot of investment. So several times economic assessments we have to carry out. Then next is environmental and social impact assessment, baseline studies. Okay, then ESIA studies. This is to develop a comprehensive report on addressing potential impacts and mitigation measures. Okay, then regulatory compliance. Okay, then uh, permission, identify obtain necessary permits whenever required, ensure compliance of local, regional, and national regulations. We have to follow by those things. Then community engagement, stakeholder consultation, those things will become under economic aspects. Then risk assessments, mitigation strategies. Then finally project timelines, that is also important. These are, as I told, these are a lot of investments are involved. So whenever there's big investments are required, you have to be time bound. Otherwise, as I have told, that EFG classification, UNSFC classification, economic axis, feasibility axis, and geologic axis. All the axes must become at least 111. Maximum all risks must be reduced. Then budget and financing, finally, cost estimates, financing plan, monitoring and reporting, regular monitoring, and finally proper conclusion, recommendation, key findings has to be summarized, then recommendation for the further exploration and development. So this is a broad overview of gold exploration. I hope this video will be useful for everybody. Thank